K0S is a simple, solid, and certified Kubernetes distribution that works on any infrastructure, public and private clouds, on-premises, edge, and hybrid. In this upcoming talk, we will get you up to speed on managing and deploying traffic as an Ingress controller on the K0S project from Mirantis with my guest Jussi Nummelin's team lead for K0S project and senior principal engineer at Mirantis, and Jakub, product specialist at Traefik. Hey, how you doing? This is Sam Sufder, the Traefik Islamabad meetup organizer, and today in this talk, Jussi will show you how to configure and install and manage K0S cluster using K0S CTL, how to set up a K0S cluster in a HA environment. You will learn the need for the K0S project, how to configure setting for deploying the K0S cluster, and also how to configure setting for deploying the Traefik Ingress on top of K0S cluster. You will also learn along the way the core primitives of managing and deploying K0S cluster. And Jakub will help you. What is Ingress? What problem it tried to solve? What is Traefik Ingress? And what are its roles and how to deploy it. And you will also learn how to deploy Traefik as an Ingress controller on the K0S project. During your journey of 1 hour, you will also learn along the way how to expose your app to the internet using an Traefik Ingress in the K0S project. And thank you everyone who showed up for the Traefik Islamabad meetup today, and warm welcome to everyone who engaged into this session from Traefik Islamabad meetup organizer Sam Sufder. And let's go ahead and dive into learning the Traefik as an Ingress controller on K0S project from.
All right. So, hey again, and thanks, Sam, for organizing another session. This time, collaborating with Jakub from Traefik side, and kind of diving into how to use Traefik as the Ingress controller with or on top. I don't know. Let's call with K0s and of course Traefik being one of the cool solutions for an Ingress controller on Kubernetes. So yeah, maybe quick intro. So I'm Jussi. I work with the K0s team as the sort of a tech lead for the K0s, and also actually here at Mirantis, I'm the team lead also for the core K0s team. Jakub, quick intro.
Yes. Hello everyone. So thank you, Jussi. Thank you, Sam, for organizing the event. My name is Jakub. I'm product adoption specialist. I work for Traefik Labs. And yes, I'm responsible for managing open source community, questions, topics. I'm trying to answer a lot of questions on our community forum. I also support our repository in regards to reproducing the issues, as well as I support the customers who are using our enterprise solution. And yes, today I'm going to present Traefik running on K0S, but after Jussi's presentation. So thanks a lot, and I will back in 20 minutes, I believe, 30 minutes. So Jussi, the stage is yours. Good luck.
All right, thanks. All right, so of course, before we can actually set up the Ingress controllers on the cluster, we of course have to get the cluster up and running somehow, and we've already had these different kind of deeper dive sessions on K0, so I'm not going to dive too super deep into what it is, but maybe a quick recap. So yeah, we went through who I am. So a super quick recap. What's actually K0s? So it is a Kubernetes distribution. So for those people who are new or newer into the world of Kubernetes, one way to think about this Kubernetes distros is like a kind of like a Linux distro. So every single Linux, they have the kernel, which is kind of the common thing for all of it. And then you have the like distro level stuff. You have the Red Hat, you have the Debians, you have Ubuntu's and whatnot, which add sort of their own higher level tooling and flavors on top of the like common kernel. So this is a similar thing with the Kubernetes. So the core open source Kubernetes stuff is at the core, like the kernel level things for the solution. And then there's this helper functionalities, kind of add-on functionalities that the distributions bring into the table. And K0s is really a pure upstream stuff. So we are not maintaining our own fork of Kubernetes. So we take the full pure upstream vanilla Kubernetes version and we just package it in as a single binary. And for us, the single binary packaging was something that was kind of like the goal from day one. So because it makes life easier in the way that we don't have to, and nobody has to maintain different flavors of packaging, different RPMs, Debians, APKs for Alpine, and different versionings of different OS versions, and the rabbit hole is super deep on packaging always. So you have so many dependencies, and then some dependency changes version, and everything breaks down like a house of cards. And but also the way we actually built the Kubernetes and other components, and of course the K0s itself, we actually get this sort of a operating system independence. Yeah, it's Linux still mostly. Yes, but there's no dependencies to different Ubuntu flavors or Red Hat flavors or RPMs or anything. So it's a single binary that you just drop in and run it, and you get everything with it. Also, one of the sort of design choices that we did early on was to really keep the K0s as sort of a bare bones solution. So we're not going to be bundling in like a lot of different Ingress controllers, for example. We rather want to keep the sort of the choice for the end users, because there are different use cases where different Ingress controllers or different volume providers or different networking providers or different this and that makes more sense. So we definitely don't want to bundle everything in. So we rather made the design choice that, okay, let's keep it pretty bare bones so users can make the final choices. One of the kind of main technical differences between other Kubernetes distros is the fact that we have this like this full control plane isolation. So by default, when we spin up the clusters, you don't get kubelet, you don't get container D or Docker or any other container runtime actually running on the controllers. So essentially, they are not really part of the workload cluster as such. So for the end user, how you see it is you don't see the controllers on the kubectl get node list at all, which means that you have zero possibility to actually schedule your workloads onto the controllers, either on purpose or by accident, because that is something that's quite often a, not really a wish, but even a requirement from like these more how to say it, security oriented organizations. One of the ways to extend K0, because as I mentioned, it's the K0 itself is quite a bare bones. So There's actually a couple of different ways how to sort of extend the functionality to drop in, for example, an Ingress controller, which I'll actually show in the demo. So you can drop in like Kubernetes manifests that, well, let's call them what they are, YAML files. You can drop them into the manifest directory. So automatically K0S will pick it up and see that, okay, hey, there are new YAML files. I'll apply it to the cluster. So it's, you can think of it like file notification based kubectl apply machinery. It's actually not that simple, but essentially that's what it does. Another way to do it is to define these extensions as Helm repos and Helm charts on the K0S configuration file, which you give into the controller. So based on this, the controller will actually install the Helm charts automatically and everything, and you have like a single definition for stir and the sort of core components of your cluster. You have a single YAML file where you figure, okay, this is the base setup for the cluster. Then you use some CI/CD pipelines and whatnot to push the actual workloads. So setting up the cluster, we've actually created this neat helper tool called K0S CTL. So it's really like a well, it's a helper tool that sort of simplifies and automates the multi-node cluster setups. So of course I could go and SSH into my node, download the K0S binary, run it, push it as a systemd unit and everything, and then move on to the next node and so on. Yeah, I can do that for a couple of nodes, but on the third node I get bored. I get bored. Humans get bored. They make mistakes. So this is like an automation tool over running things over multiple different hosts and whatnot. We build it so that it actually integrates pretty well with the infrastructure automation tools like Terraform, for example, and of course it's also super easily integratable with scripting to any CI/CD pipelines and whatnot. So it's a tool to simplify the multi-node operations. Control plane isolation that we covered already. About the high availability way that currently at least we do require an sort of an external load balance when you want to run the control plane as highly available. So there's a couple of reasons why that's a sort of a requirement. So first of all, when you configure your clients, that the kubectl that people uses should have a single point. You can configure only one address in your kubectl config. So you have to have something that actually balances the load over these multiple controllers. And of course, same goes to the nodes. The kubelet running on the node is actually calling to the API server. So you really need to have a single address that you can configure to all the nodes and other components on the nodes like kube proxies and whatnot. The true control plane isolation, because the controllers are not part of the cluster, we use this connectivity component to establish these sort of a kind of tunnels for the communication. So that is also configured through the load balancer. And currently, each of the agent actually connects to each of the controllers. So there's actually like m times n connection tunnels, so that we achieve this true high availability for the communication tunnels also between the controllers and the workers. All right, my favorite part of the sessions always, live demos. So be warned. Let's see how it goes. All right. So low motion mode. All right. So basically, I have a Terraform. Well, it's not a script, but Terraform. What are these called? Manifests. I have a Terraform file where I define. Oh my God, this is so slow. I define few VMs that I'm spinning up Hetzner as the provider. So I basically have workers, controllers. Yeah. I have actually setting both. Then I configure this external load balancer to traffic or route the traffic to the controllers, and I set it up using different ports, 6443, the Kube API, then a couple of others, 8132 for the connectivity for these reverse tunnels, and so on. Then I use this nice trick of defining these local variables where I collect information about the controllers. And here's a neat trick for the both for Terraform and then with the K0S CTL tool. So I can actually upload files using the K0S CTL automatically to controllers. So as you can see from the path, I'm actually pushing these Hetzner cloud controller manifests directly into the controllers as these manifest bundles. So it'll automatically, when the K0S boots up, it automatically actually tell me the Hetzner cloud controller, which is neat. So I can get these load balancers and everything out of box for me. As we know, with Kubernetes, you have to, whenever you use these cloud providers, we have to configure the kubelet with these extra controller things on the nodes. So for that, we have these install flags that we can use for K0S CTL, which will actually pass it on to finally to the kubelet process running on the node. Okay, what about Ingress? We want to have an Ingress, especially in this session. We want to have an Ingress on the cluster. So thankfully, Jakub and others at Traefik side, there's already a Helm repo that we can use. So I can add these K0S extensions, and I'm adding this Traefik as a Helm extension. So I need to configure, of course, what's the repo where we get the chart. Then I said that, okay, let's install this 9.11 version of the base Traefik chart. And this is actually it. This is the configuration. So in 180-ish lines of Terraform, I have both the infrastructure, highly available load balancers. I have the Traefik as an Ingress, and then it's just like Terraform apply, and after that it's a waiting game. Oh my God, my computer is slow. Maybe I should have pre-recorded this. I've been actually starting to think whether there's some real like hardware issue in my like graphics card or something. Because whenever I have screen moving somehow, it starts to fail like this. All right, yes, that I approve. And this is what I like about the Hetzner. So it takes like creating a load balancer takes like 4 seconds, and creating nodes takes like 20 seconds, and that's about it. All right, so the basic infrastructure is actually up and running. So now I'll pipe the Terraform output, because as you saw, I sort of YAMLified the output already. So I'll take the raw output as a YAML, and then I pipe it to the K0S CTL apply. And then K0S CTL will actually connect into the nodes and do its thing, configure K0s in the place and whatnot. So I'm using this this upcoming release, the beta 1 version of it. So I'm doing both live demo and using beta stuff. So
I really like to live on the edge.
So in the end, what we are actually using as the configuration for the K0S CTL is of course it's YAML, and you basically define that okay, what are your hosts, what's the SSH address, what's the SSH user, what is the role for the node, and then the K0S configuration, and that's it. So this is super easily scriptable with of course, as you see, with Terraform and basically with any other. So it's quite easy to dump YAML in YAML from basically any sort of modern tool. So I'll stop my video for a while to get some room for my local CPU, so it'll be slightly faster, I hope. All right, so we are already waiting for the nodes to actually become ready. So basically we're essentially waiting for the nodes to pull in all the needed images for the cloud controller, for kube router as the CNI and all the different node level components. So imagine how fun the demos were last week when Fastly was down. All right, so it took like 2 minutes to get the cluster up and running. Then another K0S CTL command to get the kube config. So I'm going to dump it as the K0S demo.conf file locally, so I can actually use K0S, not K0S, kubecdl. So kubecdl get node. First connection always takes a bit longer because the load balancer is sort of cold still. So it takes a bit of warm up to become like fully ready. Get pod -a. Yeah. All the pods are actually up and running. Yeah. As you can see, I've got Traefik already there up and running. And then if I remember that I pushed this Hetzner cloud controller manifests as a manifest bundle. So the cool thing now is that when I see this kubecdl get service, I have actually these publicly available load balancer addresses attached to this service on my Kubernetes side. So actually, if I hit this IP curl, well, of course I get 404. I have actually nothing configured to use the Ingress. So that's what Jakub will dive into and show you how to do it actually. So I'm gonna sort of leave it at this space, because this is where we have the infrastructure parts up and running, and now we can actually dive into the fact that maybe a bit more advanced configuration examples, how to deploy Traefik and also how to properly use the Ingress objects and Ingress configurations and whatnot.
Okay. Okay, so let me share my screen. Yes, so today I'm going to talk about the deploying Traefik on Kubernetes cluster, and Traefik will be acting as an Ingress controller. In my case, Kubernetes, it will be K0S that has been just presented by Jussi. So introduction, I already introduced myself, so let's move forward. What's the agenda? I will focus a little bit of the theory. So I will mention what is the high-level architecture of Traefik, what are the configuration components, what are the configuration aspects that you should focus while you are configuring and deploying Traefik. And I will also mention what are the two types of the integration Traefik with Kubernetes through standard Kubernetes Ingress and through Kubernetes CRD. So prerequisites is you need to just deploy Kubernetes cluster. In my case, I already deployed K0S using AWS and EC2 instances. In order to manage AWS API, I had to also deploy AWS Cloud Controller on my cluster to have a connectivity between Kubernetes cluster and AWS API in order to create specific resources in AWS, such as load balancer. Helm free is also a prerequisite because I will deploy Traefik using a Helm. You might also install Traefik using extensions that has been just presented by Jussi, but in my case, I will follow the standard way using a Helm and its Helm install arguments. Domain name, because we will be also using trying to issue certificates from Let's Encrypt. So domain name, it's something that will be nice to have, but it's not necessary to explore Traefik. So what is the high level architecture of Traefik? So as you can see, Traefik is a router. So it's a cloud native router that has been designed from the beginning to act as a router. So if Traefik is able to get the incoming request, HTTP request, and pass that request based on the specific matching rules using routers that we will create shortly, pass that request to your backend, to your application, to your pod. And integration might be done through on the different infrastructure. It might be Kubernetes, it might be a Docker Swarm, or even legacy system when you have just a bare metal servers or VMs deployed. And you can use Traefik as a standalone load balancer, and they take advantages of it even in legacy infrastructure. So Traefik is able to automatically discover what's happening in your infrastructure. I mean, what are the services created, what routers you are defining, and apply changes dynamically. So it's a perfect feature and perfect fit for modern infrastructure. So configuration overview, we have two types of a configuration. So first, it's a static that requires restarting Traefik, and second, it's a dynamic. So static, for example, is an entry point. An entry point, it might be we can understand entry point as a port that Traefik is listening to. So it's a port where all requests will be caught by Traefik. So it might be a port 80, it might be port 443 for HTTPS, but you can also open another ports for TCP routers, because Traefik also is able to route another request, not just only HTTP, but it works perfectly with a TCP, UDP, gRPC, and any other protocols that you can imagine. So those entry points requires restarting Traefik. Provider connection information also requires restarting Traefik. And saying provider, I mean, for example, Kubernetes CRD, Kubernetes Ingress, Docker, file provider. So those things are not dynamic. From the other hand, we have something that is called dynamic. We have routers that can be dynamically created based on the specific rules. Services, so Traefik is able to discover services in your infrastructure and automatically apply it on a cluster on its configuration. So no need to restart Traefik. Middleware, so those components are actually to tune your HTTP request. It may be, for example, be basic authentication. It might be a redirect scheme, so you can create a redirection. So those two I will show in my live demo, but there is also much more middlewares that you should definitely explore. For example, rate limiting, authentication to the forwarding authentication to the external provider, and many others. So I encourage you to see what are the other benefits in middlewares. Certificate stores and options, so you can store your certificates in a specific places, and you can apply specific options to your certificates, and it's perfect feature, and we will see in action how it's integrated with Let's Encrypt and how to issue dynamic certificates, how to tune TLS configuration to get a better rating, to have a more secure server. So yeah, let's move forward. So where the Traefik is placed in the Kubernetes context, in the Kubernetes ecosystem. So Traefik acts as a regular pod, right? So it's deployed as a regular pod, but acts as an Ingress controller. So in order to route traffic from the top to the application, we need to have still any external load balancer that will give us IP address. And that's why I deployed AWS Cloud Controller in order to create external load balancer on AWS. If you don't use AWS, if you use any other provider, cloud provider, or even bare metal infrastructure, you can still use, for example, Metal LP and integrate to get Traefik together with those applications. So it's running outside your cluster. Then you need to have a service type. It might be a load balancer that match ports from the outside to our cluster, to our Traefik instance. Then Traefik instance connects to the service, and the service is connecting to your pod, to your application. So once that Traefik discover, okay, I found the application, I know what to do with that request, then it just relies on the endpoints. No need to connect directly to the service. So it's that service is just needed only in the service discovery phase. So this is actually how Traefik is working. What are the other types of the exposing application Kubernetes? So we can use a cluster IP that is expose services within the cluster. We can use a node port that binds application to your node, and load balancer. Again, it's a load balancer that you can create in your cluster, and it will be exposing application outside your Kubernetes cluster. However, all of those three possibilities acts in a layer 4. But Ingress, the major difference between those three is that Ingress is working in layer 7. So you can get much more benefits from the Ingress, and in fact from Traefik. So you can create the TLS termination, you can have a named-based virtual hosts, and much more features that are providing from Traefik. So what are the providers for Traefik in Kubernetes? We have currently 3 types of the providers. So first is the standard Kubernetes Ingress, standard Kubernetes implementation of the Ingress in Traefik. Second is a CRD, so it's another layer that has been added to the Traefik to create specific resources. For example, Ingress root, middlewares, Ingress root TCP, TLS options, and many others. So it's another way how you can integrate Traefik. And the third one is the new evolution of Kubernetes. It's Kubernetes Ingress. It's a gateway API. So it's still experimental in Traefik. So in my presentation, I will not cover that yet. Okay, so I'm already done with the theory. So let me just move forward to my cluster. So I'm already connected to my cluster that has been deployed on AWS. Let me check whether cluster is up. So let's get the nodes. Yes, I have 2 nodes. What are the other pods deployed? Okay, so we have a extra pods that I mentioned. So it's a cloud control, AWS cloud controller. And yeah, we can deploy Traefik. So let's move to the first example. And we have here file that is called values, because I will be installing using Helm. And as you can see, I specified a couple of the parameters here, a couple of the arguments that I'm going to pass to Helm and deploy Traefik. There are much more parameters that you can configure. So I'm on the Traefik Helm chart repo, and you can go to the values and see that there are lots of options that you can specify. Some of them are already pre-configured. So that's the benefit why to use Helm, because you will get the Traefik that is a little bit, that's actually ready to use. You don't have to change too much to start working with Traefik. So I personally use Helm, but you can also deploy Traefik using a standard Kubernetes manifest. But in that case, we'll just deploy using a Helm. So you can review the file. It's a Traefik Helm chart repo and the file values.yam. But in my case, I just added the log level to debug. I asked to get the access log, and I passed some additional arguments to the Traefik binary that will be running in my cluster. So I created 2 certificate resolvers. So first, it's a staging environment for Let's Encrypt, and second, it's a production environment. And I ask, okay, we will use a TLS challenge to issue certificates. There are also HTTP challenge and DNS challenge, but in my case, I'm just using a TLS challenge. So yeah, let's try to deploy Traefik and see using those values and as a basic example, and let's see what we can do further with that. So Helm install Traefik, the repo name and the values. I'm passing the values. I'm in the default namespace. Okay, let me start it. It has been just deployed. So let me check what has been deployed. Okay, Traefik instance is just getting started. Let me see what parameters has been passed to Traefik binary. Traefik describe. Okay, and yeah, as you can see, the pod, that's the parameters arguments that has been passed to the Traefik. So those arguments have been added because we use a Helm. So the entry points that I mentioned earlier has been already opened. We have availability. We have a dashboard enabled. We have 2 providers, Kubernetes CRD and Kubernetes Ingress that I mentioned. And those are extra parameters that I added using my values.yaml file. So it's a log level, it's a certificate resolvers. So as you can see, all of them has been passed correctly as arguments to my CLI command, to my CLI binary. Okay, so let's check what else Traefik deployed. So as you can see, it has deployed load balancer, and this is actually the IP address, actually the name that has been created dynamically on AWS using a cloud controller. And now our Traefik is exposed using that URL. So now we would like to have any nice domain to play with that. So I will create DNS entry that points to that CNAME. So I created a very simple script to update my DNS entry. Okay, so let me execute it. It will take a while to propagate. Okay, it's done. So as you can see, we will use a domain k-demo trafiklabs.tech, and it points to that CNAME record. Okay, so I think we are good here. So let me now see what has been also deployed. So we have an Ingress root. So it's a Traefik dashboard, dynamically deployed, automatically deployed. Let me create port forwarding because we can start to explore traffic. So that's the command that will create connectivity from my local computer to the pod, directly to the pod. Okay, so let me start it. The forwarding from localhost to the port 9000, and I can go to the localhost dashboard. And yes, this is the standard dashboard that Traefik is deploying. So we have entry points, we have HTTP routers, we have TCP routers, we have UDP routers, features that has been enabled by values.yaml, and providers. So those are already added here. As you can see, that's actually the dashboard that we are able to see right now using a API internal service, provider Kubernetes, and it's actually a health check to making sure that traffic is healthy. So it's a liveness and readiness health check props provided by Kubernetes. So services, so there are just internal services that are required to have the traffic up and running. So yeah, let's move forward to the next lesson, 02. And now we will deploy very simple test application. So it will be whoami, standard whoami application. So apply, let me open the file first to see what's inside. So it's just a regular Kubernetes deployment. Let me deploy it. Apply -f whoami deployment. Yes, that's deployed. And now we need to deploy service as VC that match the deployment. They are just deployed. Okay, so key apply -f whoami as VC. Yes, that is deployed. Let me check whether pod is up and running. Yes, whoami is up and running. And now I should also have endpoints available. Endpoints. Yes, so our application is available to that endpoint inside the cluster. So it's cluster IP. So this is why I explained another options to expose services within the cluster. But in order to outside that application outside the cluster, we have to create actually Ingress rule. So let me do that in the next lesson, in the next example. Okay, so I'm just opening the ingress.yaml, and it's a standard Kubernetes ingress. The only change that we are adding here is annotation. So we are exposing whoami application using that service on the port 80 using the entry points web that we defined in our configuration, and the application should be available using that URL, that domain that we'll just created. So let me check if the DNS propagation, let me first deploy it. Ingress.yaml. Yes, that's deployed. Let's go to the routers. Yes, it has been correctly added. So each request that has that use host header, that match that host header, that name, and the prefix is root, will be passed to the service, that service. So let's go to the services. As you can see, service has been automatically created by Traefik, and we see that there is one backend, actually one pod that is exposing the application. Yes, so we should go to we should first check if we can use the Ingress, if the domain has been already propagated. So dic plus short whoami k demo traffic labs.tech, and I should receive the CNAME and IP address. That's IP addresses. That's correct. That means that our application will be accessible using those IPs. So if I will go to curl HTTP, because this is HTTP, who am I, K demo traffic. Yes, I'm getting the application. So everything works fine. Traefik was able to get the request using the HTTP host header and using the load balancer for IP addresses from AWS, pass that application directly to Traefik and then to the backend, to the backend of my with the Who Am I application. So works perfectly. And now let's do the same, but we would like to issue certificates. So let me create another router, but with the HTTPS. So what are the differences here? So as you can see, we have added another 2 annotations. So first we change the entry points to web secure because we would like to have application available through HTTPS. We created annotation to say, okay, we would like to use TLS, and the certificate resolvers that I added in my values YAM in the first example should be LE. So we are going to issue certificate from the production Let's Encrypt servers. So we should have a valid certificate. Okay, so let me deploy it. So we should receive the same content. However, it should be also added by, it should be reachable through HTTPS. HTTPS. Yes, it has been added. In the background, Traefik is issuing certificates. It talks to the Let's Encrypt server, hey, I need a certificate. And that challenge should be successful, I believe. Let me go to see what has been changed in my cluster. Yes, we have a new rule. As you can see, that's a TLS rule here. We have a specific icon here, meaning that it's a TLS, protected by TLS, the same service, so we should expect the same content. Okay, so let me check HTTPS, who am I, and we should get the application. Yes, it works correctly. Let me check what certificates has been issued. And as you can see, we issued the valid certificate. So it's the TLS termination is correctly configured, and Traefik was able to talk with Let's Encrypt and issue certificate for us. So everything has been done automatically because I use a specific annotation. So we are good. We can go further to another lesson. But in the meantime, I will try to validate how strong is my configuration. So I will try to check SSL Labs. I will use SSL Labs to validate my quality of my configuration. Okay, who am I? K demo traffic labs.tech. Let me run that tests. It will take a while, so we will focus on another things. Okay, it's running in the background. As you can see, it started using those IPs. Let's move further. Redirect scheme. So we will create the middleware to redirect from HTTP to HTTPS. Redirect scheme. Okay. So what is it here? So it's object middleware that will redirect from each request from HTTP to HTTPS, and it's set permanent flag. So let me deploy it, and then let me apply it to my Ingress objects that I created. So key apply, redirect scheme YAML. Yes, that's applied. So k get middlewares. It's added. Let's go to middlewares. Yes, you have a new middleware. As you can see, the naming convention is a little different because the first is the namespace, because we are deploying our examples in the default namespace, Kubernetes namespace. That's exactly the name of the middleware and the provider. So Kubernetes CRD. So that's deployed. We are good. Now let's go further and let's try to create redirection, automatic redirection from HTTP to HTTPS. So there are a few changes that are required. The first change is to just add, the first and the only one change is to just create add the middleware on the HTTP Ingress. So the same entry point and also just the default redirect scheme Kubernetes CRD. So that's the full name of the middleware I created. Okay, let me apply it. Ingress web, it has been applied. Let's go to see whether it's applied. So that's our Ingress. And yes, we have one middleware that has been applied, and it's a redirect scheme, provider Kubernetes CRD, and it's redirecting to HTTPS. Okay, so let me check whether if I will send the request HTTP, I will be redirected to HTTPS. Yes, I'm redirected -L, and I'm getting the content of the application. So works perfectly. Of course, you can create a global redirection using entry points. However, that's the one of the example how to use middlewares. Let's go to the 06, and now we'll use a CRD. So it's we will expose the same WhoAmi application, but using the Ingress root CRD. So it's the standard, it's a custom resource definition provided by Traefik. As you can see, it's a CRD because API version refers to the Traefik containers. And the kind is an Ingress root, some metadata, entry points, roots, and the rule, the matching rule. And in that case, we are using just host header to match our application. So let me just deploy it. And yeah, the same service, the port 80. So k-apply -ingress CRD. Correct, it has been deployed. Ingress root. Yes, that has been deployed. Let's go to the console to see. Yes, it has been added. Yeah, the same service. So curl HTTP CRD K Traefik labs. Yes, and we are getting the content. So everything works as expected. Let's see, maybe our test has been finished. Not yet. Actually, it's grade B, so it's still continue. Now let's move to the 07. And now we will deploy Ingress CRD using the web secure. And the configuration is much more complex here because I wanted to show you more options. So we create another object, Ingress root, CRD, HTTPS. We are using two matching rules in that case. So I would like to have that WhoAmi application will be available using two different URLs, CRD and CRDA. So that's the actually or parameter or a logical argument added here to distinguish these two URLs. The same service, and I'm adding the new security middleware to have a more secure server because I added extra headers to have a more robust server, more robust SSL server. And TLS options. This is actually another middleware, custom resource middleware that we are they're adding here, and it provides it sets minimum version of a TLS, adds some extra cipher suits and other parameters to again make it more robust. Let me deploy it and let me test it using the SSL labs, and we'll compare what are the differences. Same applications, I mean WhoAmi applications, but two different type configuration, and we will see what Traefik can do with that, and we will see what grades we will get. So key apply -f Ingress web secure. It has been applied. So let's go back once again here, and let's start testing against that URL, kdemo Traefik labs.tech. First, let me check whether I have a certificate issued because it might take a while. CRD. Okay, it's up and running. Certificate has been issued. As you can see, the first request failed, but the second already gave us a correct response, expected response. So that means that we are using the valid certificate. Yes, the certificate has been just issued. Okay, let me push the button, submit, and start testing. Yes, so as you can see, that has been finished and we received the grade B. It can be better, right? We can tune a little bit our configuration. And this is actually what we have just done by deploying the unable to resolve domain. Yes, that's the typo here. Okay, it works. So it will take again a while and we will come back to compare what results we'll get. Please remember that we added some security headers here. We tuned TLS configuration by setting up TLS options. And yeah, let's move forward. And now we will just create the basic authentication, because we'll like to use that basic authentication to protect dashboard, because again, we are using a local host port forwarding, but we would like to expose the dashboard using a dedicated URL. Okay, so how to do that? First of all, you need to create just the authentication file using a standard HTTP password. So HTTP password, admin, that's the username, the password that I'm going to use, it will be password. Let's redirect the output to the file. The file has been created, and now we need to create Kubernetes secret, standard Kubernetes secret, and that secret will be using in the basic authentication middleware. So let's create the secret. Secret generic kubectl create secret from the file. Yeah, it's already created, already exists, because I didn't delete it. I didn't delete before my test. Okay, nevertheless, it's created. So let's use a basic authentication middleware that will be referring to that secret. Okay, apply basic out. Okay, it has been created. Let's try to see to get the data from admin secret and to see whether we have a correct values. Yes, we have. Yes, and we are going to further to create dashboard that will be accessible using the dedicated URL. So Ingress CRD. Yes, another Ingress route we are going to create. The name will be dashboard. The entry points will be web secure, and the host will be that host, and the path prefix dashboard or API. And we are redirecting to the Traefik service that is another abstraction layer on the top of the standard Kubernetes service, and the name is API. But we are also assigning the test authentication middleware here, and we would love to issue certificates. So let me deploy it and see what will be the result. Okay, that has been deployed. Yes, so let me check whether our test has been finished. Yes, it has been finished. As you can see now for CRD, we are getting the A+ grade, so it's super good, very good rating. Still, we can have some room to tune it, but we are absolutely more safer and comparing to the standard installation. So that's perfect solution, perfect result. Let's see the Ingress CRD and to see the dashboard is up and running. HTTPS D 404, that is expected because we need to pass the prefix. Yes, works perfectly. Let's go to the website. HTTPS DK demo Traefik labs. Yes, and we are getting the prompt to pass our credentials, so admin and password. Voila, it works perfectly. So we expose dashboard using the dedicated URL, we issued certificate, and we have the same dashboard that we are using during the live demo, but available through the specific dedicated domain. We can do the same to see what are the other API, for example, API row, not dashboard, but it's a URL, it's not correct. Yes, raw data, and we have all specific data that we can take from the Traefik API using that dedicated URL. So I think that's all what I prepare for today. Thanks a lot, and let's try to ask some questions if there are any. Thank you very much.
Cluster is really simple and clean up, and on top of building a new thing to the cluster and managing the ingresses and service meshes and all these kind of fancy stuff, the things got a little tougher and tougher as going on. So I have
absolutely.
and I have some question from the audience that I have sent me out some emails or regarding some of the one working on the K0S cluster and the Ingress. So I first go to the Jussi side. So I think one of the people audience question is around that whenever we do to the K3S cluster and the micro K8s and the kind cluster, they have some pre-packaged built things up. Let's say that the K3S come up with the default Ingress controller. I think the Traefik is a default they are using. Then they have a CNI controller, Flannel they are using in the K3S cluster. But I think the K0S, we see a Cube router is a default plugin, but we don't see the default Ingress controller for that. What is the obvious reason for that the people are listening to us understand why you choose that route?
The main reason is that there's like 10 plus different Ingress controllers out there, and also an Ingress controller is not really a mandatory thing for the core cluster. Yes, most people use Ingress controllers, of course, but it's not really a mandatory thing that you have to have in the cluster. Like for example, Cube router as a CNI. Well, CNI is sort of a mandatory thing. You cannot get cluster up and running without a CNA. So therefore we really didn't want to make the choice in behalf of the user that okay, what's the Ingress that everybody should be using. Yeah, I know K3S and micro K8s and everything else. You have flags to disable the default Ingresses. Yes, but maintaining that is like it's not really like core of K0. So maintaining those Ingress controllers and whatever is required and needed on that, it's extra effort for the core team. So we wanted to take that sort of away at least currently.
Yes, definitely.
I know there's been a lot of discussions and a lot of requests to have some default Ingress, but then again, it's like deciding which is the default one. It's like flipping a coin.
Yes, definitely. Yeah. And I think the one thing I like about the people are talking about that the K0S and other Kubernetes distro, they were very fast way, but they have some integration point that you showed up. How you can easily configure and install the settings for the K0S cluster by choosing the appropriate cluster for your time. And Jakub shows us that's how easy it is running the Kubernetes plus Ingress controller in the K0S. So I think that before I go to the Jakub on Traefik's question that I pick from the audience, the next obvious question, I think one of the people asking about the K0S things that I think K3S is defaulting the fork repo of the Kubernetes. But K0 is not forking any repo. It's the upstream Kubernetes. What is the headache involved in managing the fork repo versus the upstream Kubernetes that the K0 is using?
Well, I dropped the ball here and literally my stress ball. So
yeah.
So maintaining a fork is actually it's not really a trivial thing. So it shouldn't usually be taken lightly. Over the times, the sort of changes on the fork that K0S has been doing, it's actually going down. Like there's not many things that they actually change nowadays anymore. Thus, the effort for them is probably a lot less than it used to be. In our case, because we don't actually use any forks to build the Kubernetes components, well, for us it's just like git clone in the build process. So there's no effort for us, but in general, I think that there's not really like from the technical point of view, there's not really like a big change, whether it's pure upstream or whether it's a sort of a light fork of the upstream repo. One of the things that is always slightly problematic in the world of Golang in general, and especially with Kubernetes. So once you have to deal with these Go module dependencies between different repos and whatnot, then things might get slightly ugly every now and then. And that's one of the things that basically every single Go project has to deal with. So
Yes, definitely. One of obvious reason is that the Kubernetes has 3, I think, updates every year. So managing the fork repo and then integrate those changes into that, I think it's a very hectic process for the team compared to the upstream Kubernetes. So I think go to the traffic side. I think the one of the first question came up when the K0S cluster is first spun up and the Ingress come up. What are the 3 or what are the stages, or let's say we call it, what are the 3 pre-planned things what people need to do when the K0S cluster is come up and has Ingress inside it, and when I have to run the application, what are the things we do first up? What are the plans for managing the Ingress in the K0S, or the best production strategies, or you want to suggest with our audience?
Okay, so it's for me.
Yes.
Yes, so the best strategy. So first of all, if you are using the Traefik, you need to decide what kind of Ingress you are going to use, what kind of Ingress provider you are going to use. Because as I mentioned in my presentation, there are for Kubernetes 3 types. So it's a standard Kubernetes Ingress, it's an Ingress root, and the experimental way of gateway API. So we try to present today Ingress and CRD. So the question is how you are going to create actually Ingress resources, if you are going to use a standard Kubernetes Ingress or CRD. So it's a strategic decision, but I would definitely try to use CRD because you are getting more from the traffic. You can use a middlewares. You can the configuration is much more human friendly, readable, I would say. For Kubernetes, standard Kubernetes Ingress, if you have any other Ingress controllers deployed, definitely I would use a Kubernetes Ingress. But if you are deploying Traefik from scratch, I will use Ingress root because for me it's easier. I understand that naming, that the CRD that are created in Traefik. So that's, in my opinion, the most important decision. The second is how to keep the entire configuration, but it's true for entire Kubernetes, how to keep the configuration up to date with what you are in your local repository. So you need to think about any GitOps tool to deploy the configuration in order to have one source of truth. So it's absolutely something that you need to think about it if you are managing the Kubernetes in production. So I think that's all.
Yes, definitely. Thank you very much for this explaining all these kind of details to us. So wrapping up all the things, we have wonderful session from K0S team, from the Jussi and the Jakub. They are showing us how easy it is to run the K0S cluster and then how to manage the Ingress side of things with Traefik. So this is the first session we can do it, and hopefully we try out the use cases of your audience, what you want to see next in our webinars. Either you might be interested in some GitOps things with the K0S team, you might be interested in how to do GitOps thing with the Traefik side. We try to find out these experts moving forward. And thank you very much, Jussi. Jussi has been shown up for the 3 webinars, 2 of them conducting the Cloud Native Islamabad, and I'm very happy that people are getting interest in learning from these webinars, and I see the audience keep growing up and watching these sessions. And this is my first session with Jakub, and I'm really interesting. He spent his time, he's a very busy person, doing a lot of stuff in the Traefik ecosystem, in the Ingress controller side, and I try to engage with these 2 people in the future, and hopefully we can conduct a session from your use cases, what you want to see next in the K0S and the Traefik side, and we can do a 1 hour of session of running the managing and deploying the Ingress and Kubernetes K0S in the production best strategies, and might be doing some GitOps things. But thank you very much everyone who listening to us today, and that's all we have for the today's session, and we hopefully try to keep in touch with you in future as things keep evolving in the container ecosystem and the cloud native ecosystem. Thank you very much for spending your time with us. Thank you, Jussi. Thank you, Jakub. Hope to see you again in the future. And
Thank you.
Thank you. Thank you. Bye-bye.
Bye.